This video goes through several solutions our team found to problems with existing products. We will explore 8 different products, walk through their problems, and explain the solutions we found to make them better. The first product we chose to look at was an easier method to raise and lower dorm beds. If you're a college student, you know the difficulty associated with just moving your bed up or down a few inches. You have to take apart the whole frame, by yourself usually, in a very confined space, and it often ends up leading to injury and is really difficult to do in a lot of campus dorms. Some of the current solutions to this problem are external risers, which really just raise the bed a few inches if really make any impact at all, and just manually adjusting using a hammer as seen in the picture on the right. It takes a while and it's not easy and often leads to a lot of injury, like I said before. A solution we found to this problem was implementing vertical farm jacks in each leg of the bed. These jacks allow the bed to be adjusted incrementally without having to take the entire bed frame apart. This helps the process take up less space and reduces the risk of injury. Each farm jack can go up to 4 feet from the ground in adjustment. The frame is attached to the back of the farm jack and rests on its lifter. As far as the construction of this solution goes, the farm jacks are standard McMaster-Carr parts that can easily be purchased. The wooden legs are simple cut beams that attach to the farm jack and are more for looks than function. Our solution tried to minimize the number of parts used to make the installation economical and efficient for universities to implement. Next, we decided to take a look at musical instruments. Grand pianos are one of the most common types of pianos found across the world. One issue they have, however, is that the main lid is quite heavy to open up. It can very easily injure fingers or limbs if not opened properly or by someone with enough strength, making it a problem for older players to use. We wanted to create an attachment that would allow the grand piano lid to open easier and not close as quickly, preventing hands from getting caught under the lid. Our solution was a soft close attachment for the piano lid. This attachment uses a gas spring, similar to those found on a car trunk, to slow the descent of the piano lid. This gives enough time for hands to move out of the way and aids in initially opening up the piano lid. The attachment simply slides over the left edge of the piano frame and only has one screw installed on the piano lid. Regarding the materials and manufacturing process for this, most components are steel or standard parts. The gas piston and spacers, along with the screws, are standard parts that can be purchased from a supplier. The only custom parts are the stamped sheet metal frame and lid mount, which could easily be mass manufactured due to their simple geometry. Similar to the last design, standard parts were used and numbers were reduced to make installation easier.
We've all been there. It's summertime, the sun's shining, it's at least 95 degrees outside. And you stock up your cooler with cold beer, dump a bag of ice in, and leave it to sit. However, when you come back and try to open your cooler, you find that you can't really open it. The pressure in the cooler has dropped because of the ice, and the seal of the cooler is so good that you can't open it. So with this new product, you can kiss that problem goodbye. By incorporating a rubber stopper into the lid of the cooler, you can easily equalize the pressure before opening the cooler, allowing for it to be opened like normal. Both the cooler and lid are made of a patented plastic that is rotationally molded to ensure solid walls, therefore solid cooling. The plug, on the other hand, is made of a synthetic rubber and will be injection molded for simplicity in mass production. Another warm weather problem Lawn mowing. You're a strapping young man and you go to start your lawnmower. And instead of it going something like this, the pull cord snaps. Now, instead of mowing when it's nice and cool and you can enjoy being outside, you have to pull apart your lawnmower's ignition assembly and reattach the handle to the cord. But this is a problem for past. By incorporating an aluminum disc into the weave of the cord will catch on the outside of the ignition unit, saving you hours of headache. The aluminum piece we made by stamping it from sheet aluminum. Therefore, they can easily be produced in mass.
One of the biggest issues with kitchen oil containers is controlling the flow of your liquid one-handed, often while multitasking. So we shared 3 of the most common designs on the market right now to highlight this problem. And as you can see, the first model relies on gravity and has a little latch that opens, but that causes a sudden pour or sudden burst of oil and an uncontrolled flow. The second model has an open flow, which allows for a more predictable flow, but requires a cap, which is often inconvenient to remove. And lastly, the lever option shows more promise, but is awkward to hold and press and does not close on its own. So to ensure a good product, we must take all these designs into consideration and build upon them. To solve this issue, we decided to come up with a lever design that would reach your hand as you hold the bottle comfortably, along with a spring that puts it back in its original position. Over on the left, you can see the product in action. As you press the lever, it engages the nozzle or the oil, and as you let go of it, it stops the flow and no oil comes down anymore. Over on the right, you could see the cap with the bottle put on, with the rubber seal and gasket that prevents the oil from leaking, and the lever is in a position where your hand would normally be, which allows you to do everything one-handed while multitasking. When it comes down to material selection and manufacturing, we have 2 main parts of this product. The first one being the nozzle and gasket. So the nozzle is made out of stainless steel, and the manufacturing process, it would be cut and then stamped to shape and then polished at the end. We use stainless steel because it's food safe and resists corrosion. Now, with the gasket, it needs to prevent the oil from leaking out, which makes rubber an obvious choice, and it's molded into shape, cut, and finished to our product. Now, when it comes to the actual lever, the main body is made of ABS plastic, and it'll be injection molded as it provides the most flexibility and rigidity. And since it's a complex shape, it would be hard to do another manufacturing process. For the actual spring that allows the lever to go back to its original position, we use stainless steel as it has enough springiness to put it back without without wearing out the spring. The steel would be cut and then pressed into the flat spring that we have. Our next product relies on the fact that kegs are bulky and we need to transport them somehow. So the first option would be a dolly, but that's costly and bulky. You can't store it, and then once you drop off the keg, you got to bring it back and deal with the whole thing. The second one is a more sleek option, which is the 4 wheels, and you place the keg on top on this plastic base, and it allows you to roll it around. The only issue is once you've got it to the position that you want, the keg now is always rolling and it's not stable, which means you'd have to remove it and put it back on every single use. That said, we decided to come up with a hybrid product that incorporates both the elements of the dolly and the wheelbase that we saw. So similarly, it would be a wheelbase that you would clip on. As you can see on the left, it is just a regular plastic base with a caster wheel and has a little leg so you could put back the keg where it is and then it's not mobile anymore. Over on the right, you could see the product while it's used. You would have two of the same products, so you would clip them on both sides, and then you could roll the keg using the built-in handles that every keg has, and then deposit it on the legs, and it would be ready to use. You would never have to remove it until you actually refill it. When it comes to the materials and manufacturing, so you could see the main body is made of ABS plastic, and it's also injection molded. ABS plastic allows for a pretty rigid structure that is still flexible enough for us to clip the keg onto it, because we wouldn't want to deal with screws. So the plastic allows for a good balance between resisting the weight of the keg and actually being able to clip it on. And then when it comes to the caster wheels, it would be a very inefficient process for us to have to manufacture caster wheels, because we would need a whole new assembly line and it would cost us a ridiculous amount. So we decided to opt for purchasing them instead, as you could buy caster wheels in bulk and for very cheap. And then they're just simply bolted on the product.
Our next product is a device that can be used while taking a shower. In many cases, a user will use a handle in their shower to switch between hot and cold water. This is a very general and broad scope, which means that it's difficult to repeat a desired temperature that's very specific every time that the user might like. The only product on the market right now to combat this is a digital thermometer shower, which requires a whole new setup and is very expensive and not practical for many people. So our product aims to fix this. As seen on the left, our product is a suction with an arm attached to it, which can then simply be attached to the shower wall. The arm serves as a physical marking or reminder, which the user can place anywhere on their shower next to the handle of where they would like their water temperature to be in the future. From there, the user can simply use their shower like normal. In this case, they simply just move their handle to align with the arm of the suction device. Now, they're at their selected water temperature, which is what they want. This case, there's no guesswork, and they can easily get the same shower temperature and result every time. For our shower auto temperature suction device, silicone rubber has been chosen as the main material used to manufacture this product. Rubber is useful here because it is not too expensive. It has good suction properties, meaning that it will be able to stick to the wall and stay there very easily, as well as being water resistant, which is definitely a key requirement in order to be in a shower. This product will be injection molded. Our next product involves Apple AirPods. The case the AirPods come in provides little protection, with only a magnetic strip that can be used in order to keep the case shut. However, with just a little bit of force, the case can quickly and easily be opened. So that means that if the AirPods case is dropped, the AirPods can fly out and become easily damaged, which can lead to costly and or frustrating repair processes, which means that we are looking for a way to fix that. As seen on the left, our product is a case for the AirPods. While AirPods cases do exist already, many of them do not include a lock, meaning that if the case is dropped, the AirPods could still easily fly out, therefore being ineffective. Also, while there are cases that do exist with a lock, many of these lock designs can be easily jammed or worn down, therefore also being ineffective. Our design aims to fix both of these problems while still protecting the AirPods by attaching a slider that can be attached and slide in a groove, which can then be used in order to make sure that both pieces of the AirPods case cannot be moved once in place. For our slider lock AirPod case, silicone rubber is chosen as the material for the two pieces of the case itself. This is because rubber is very useful when it comes to resisting visible wear, which the Apple AirPods are likely to undergo, as well as to absorb shock from any drops, therefore keeping the case protected. In this case, these would be injection molded. As for the slider, it'll be made out of ABS plastic. This is chosen because the plastic is very rigid but also can be flexible enough to be snapped on, therefore not having to have any screws in order to create our product. Again, this would be injection molded.
We hope the solutions in this video were unique ways to address product issues and give these products greater functionality. Thank you for watching.